Hey class, today you're going to practice what we learned yesterday on how to make a protein. Remember, proteins are important because they build muscle, bone, skin, hair, nails, and they do impact the way that we look. They help to make up our physical characteristics. And so what you're going to do is you've been assigned a fictional character. So mine is Snoopy, but there are other ones. You might have Snapple or Snickers or Snuffle. And you're going to find out what this organism looks like. So to do that, you need to do protein synthesis. You need to find out what proteins make up this organism. The first step, if you look at the top, says step 1. You're going to transcribe the DNA into RNA. Remember, transcribe means to copy. So you're going to make the copy of DNA. Remember, in a cell, this occurs inside the nucleus because DNA is always found in the nucleus. So I'm not going to do all of them, but I'll do a few of them. So if you look here, you say what goes with T in RNA, and remember it is A, just like with DNA. Here's the only difference. A in DNA would be T, but in RNA, A goes with U. So we put U, and in C, C goes with G. Okay. The reason why it's grouped into threes is because remember, when we're making a protein, the instructions are read in codons, and codons are a group of 3 letters. Okay, I'll do a few more. C would go with G, A would go with U, T would go with A. A would go with U, G would go with C, G would go with C. G goes with C, A goes with U, G goes with C, A goes with U, T goes with A, T goes with A. So I'll stop there. Okay? So that is the process of transcription I just did. I made a copy of DNA into RNA, and again, this would occur inside the nucleus. Now, this still doesn't make any sense. We still don't know what this means. So now we need to begin this step of translation. We need to make sense of this code. And what happens is in the cell, this RNA code here would leave the nucleus. It would then travel to the ribosome, and then the ribosome would translate this code, okay? Because that's where proteins are ultimately made. To translate this, you need to use an amino acid chart. These are codes of an amino acid. And remember, amino acids are the monomers or building blocks of DNA. So you're going to take your other paper that looks like this, and you can either use this top portion or you can use this bottom portion. I'm going to use the bottom portion. I'm sorry that it's a little unstable here because I'm holding it with one hand. Okay, so if you notice, my first code, it says AUG. So I'm looking at AUG. So I look here and I try to find AUG. So here's A, there's U and G, AUG, and it stands for the amino acid MET. Okay, so I'm going to write MET underneath. Okay, now let's look at the amino acid GUA. I find the amino acid GUA. There it is, GUA. This stands for valine. So I write valine underneath. Okay, now I have UCC, so I look at my amino acid chart. UCC stands for serine. So I write serine underneath. SER. Then I have CUC, so I try to find CUC. CUC stands for Lu, so I write Lu. And then UAA. UAA stands for Lu as well, so I'm going to write, or I'm sorry, that's UUA. Nope, I'm messing you guys up. UAA is right here. Make sure you guys double check your work because you might be like me and look at it too fast. UAA means stop. Okay. Stop means that's the end of the instructions. Here's something you need to remember. As you're doing this process, anytime you see the word MET, that means that's the start of the instructions. That tells the ribosome that the instructions for a trait is now beginning. And then anytime you see stop, that means that's the end of the directions. So anything in between a start or MET and a stop is a code for a trait. So I'm going to circle that. It's between a MET, it's between a stop. That's important. Val, Sarah, Lou. Now what you're going to do is you're going to look at the front of your paper that you were given. Okay, so this is my first gene. This is gene 1. This is the instructions for the first gene. So I look over here. I look at gene number 1, Val, Sarah, Lou. That's what I have on my paper, Val, Sarah, Lou. And so Val, Sarah, Lou tells me that this creature is hairless. So this creature is bald. Okay. So I'm going to write hairless right there. So I know that my creature is hairless. Okay? So that's the code. Now I need to find the instructions for the second trait. So I need to keep doing this process until I find another MET. Okay? So not all these codes are important. So for example, if I do this one, GCG, GCG means, if I look here, GCG means ALA. So that's not a MET, that's not important. So I'm not going to even worry about that one. TAC stands for AUG. AUG, if I look here, AUG stands for MET. That's the one that means start. Okay, see how it's in bold here? That means that's important. MET means start. So that's the start of the instructions for my next trait. So I'm going to write MET underneath. And now I know that starting here, this stuff is going to be important until I get to an amino acid that says stop. And then I'll look at my front page here to know what it stands for. Okay, so if you need help, you can rewatch this, rewind and replay, and you can then raise your hand and I will come and help you.